We've talked about what the climate is. We've talked about what controls it, at least at the very high level. And we've walked through the detection problem to show that climate is changing. We now know unequivocally for a fact that the Earth's climate is changing. It is warming. Now we want to understand why it's changing, because in order to do something about it, we need to understand a little bit more about the causes. And so in order to focus on that, we're going to have to get into a discussion of climate models, climate modeling, and how we use those modeling exercises to understand the drivers of climate change. And for that, I'm actually going to call in two of my colleagues, Amanda Lynch and Baylor Fox Kemper, both of whom are in the Department of Earth, Environmental, and Planetary Sciences here at Brown, and both of whom are experts in climate change. Before we get to that interview, though, I want to walk through just a couple of ideas that will sort of help set up the conversation that we're going to have. The first is about what are the possible causes of global warming. And I want you to first understand that if the whole Earth system is warming, that is the air and the ocean and the land, it must be because of a change in Earth's energy balance. If just one part of the Earth system was warming, you could imagine that there was a transfer of heat from one place to another. For example, as you saw in the video we watched a little while ago, there are some times when a particular region cools and another region warms. That might be just because heat energy is being redistributed around the Earth's surface. But if the whole system is warming, then it must be a result of a change in Earth's energy balance. So that's one idea I really want you to hold on to. So that could mean that either that there's more energy coming into the system, it could mean that there's less energy being reflected and therefore more energy being absorbed. So imagine in this case putting on a black shirt versus a white shirt on a hot sunny day, right? Or it's also possible that less energy is escaping back into space, right? Because we've changed the characteristics of the blanket, the greenhouse blanket that is keeping the planet warm. So in order to think these through, we're going to go through some plausible hypotheses. One hypothesis is that the sun is getting warmer, right? That would increase the amount of energy coming into the system, and actually you wouldn't need to warm the sun very much to radically change the climate. It could be that warming is coming from the Earth's interior. We haven't talked about this in this class so far, but the Earth is still cooling from its initial formation. The interior is much warmer than the sort of cold outer shell where we live. And it is possible, it's plausible, that there could be more warming for some reason coming from Earth's interior, but we can quantify that. I'll come back to it. It could be that ocean circulation is changing, although I've already mentioned why that's improbable in terms of being an overall driver of heating the whole system. And then there are other possibilities that actually we're going to need to test a little bit more rigorously. One is that we've actually changed laws and reduced the amount of pollution that's going up into the atmosphere. And the reason that that could have an effect on climate is because that pollution could have been blocking out some sunlight. And in fact, reducing pollution, like soot particles, for example, might actually let more sunlight in to help warm up the planet. It could be that deforestation is causing warming by changing the surface color, for example, by cutting down a green forest and replacing it with a brown farm field. That could increase the amount of energy that is absorbed. And of course, it could be that greenhouse gases are changing in concentration, right? And that would change the sort of quote unquote thickness of the blanket that's keeping us warm. So I want to talk about the first few of these and dismiss them or convince you that those are not the case. And then we'll move on to the ones that are actually plausible hypotheses that need to be investigated more rigorously. So first, let's just talk very briefly about this hypothesis that the sun might be getting warmer. And by the way, these are all hypotheses that sort of people bring up when we talk about climate change. Oh, couldn't it just be the sun is getting warmer? Or couldn't it just be that ocean circulation is changing? You'll often hear this from people who are unconvinced that humans are driving climate change. So, is the sun getting warmer? It actually isn't. What we're seeing here is temperature in red and the solar activity averaged over 11-year solar cycles in blue. And what you can see is that the real warming of the Earth system that's occurred since the 1980s is not correlated with a change in solar activity. Solar activity is not increasing, but temperature is. So the sun is not getting warmer. There's actually another way that we can argue against this. If the sun was getting warmer, it would heat the whole atmosphere. because that heating is coming from the outside. But actually what's happening is that the warming is occurring really only in the lower atmosphere, which we call the troposphere, and that's where greenhouse gases are concentrated. And in fact, cooling has been occurring in the upper parts of the atmosphere, which indicates that there's something about the amount of heat that's escaping from the Earth system that's changing, as opposed to just a change in the inputs. That is, the thermal blanket of greenhouse gases in the troposphere, the lowest 10 kilometers of the Earth's atmosphere, is potentially trapping heat that's escaping, and if you increase the sort of strength of that blanket, then the upper atmosphere will actually cool, and that's what we've been observing. Although in very, very recent years, it is possible that even the outer upper part of the atmosphere is now slowly beginning to warm. So the sun is not getting warmer, and it is not a cause of warming. Another plausible hypothesis is that warming is coming from the Earth's interior. So this is a map of heat flux through the Earth system. For those of you who have taken any geology classes, you'll know that the major heat flux from the interior of the Earth out to the surface comes through mid-ocean ridges. This is places where tectonic plates are spreading apart, and you have long chains of undersea volcanoes that are transferring heat from the Earth's interior to the Earth's surface. And that is an energy flux to the system that actually we can quantify. But if this were the driver of warming, it would require a 20-fold increase in the flux of heat over the past several decades for no discernible reason, and we have no measurements to suggest that's the case. So given that tectonics is a million-year timescale kind of activity, there's no plausible reason and no observations that support the idea that all of a sudden the Earth's interior is sending way more heat to the surface. So we can reject that hypothesis. I'm going to just talk very briefly about ocean circulation because it'll come up in the interview that we're going to do in the next part of this module. So it is possible, and in fact, ocean circulation is changing. So is that a reason that the whole Earth system could be warming? And the answer to that is no. And the reason it's no is because ocean circulation is simply redistributing heat. So what I'm showing you here is sort of two pictures of the Pacific Ocean, the equatorial Pacific. One during what we call El Nino conditions, when you have anomalously warm water in the eastern Pacific, and one on the right that we call La Nina conditions, where you have cool water. So the El Nino, La Nina oscillation cycle, which occurs on sort of 5 to 7 year timescales-ish, is sort of a giant sloshing of water back and forth in the Pacific Ocean. And that's redistributing heat from one place to another. And it has profound effects on climate in North America and in South America, but it's not changing the total amount of heat in the system. It's just moving it around. And so while this is very important for any year's weather, it's not making the whole Earth warmer. It's simply changing whether that heat is in the ocean or whether that heat is in the atmosphere. That leaves us with these last three hypotheses, that reducing pollution is letting more sun in, that deforestation might be causing warming, and that changes in greenhouse gas concentrations might be causing warming. And for how we understand not just if these are having an effect, but how big an effect they're having, I'm going to take us now to this discussion with Dr. Amanda Lynch and Dr. Baylor Fox Kemper, and we'll talk about the details of how we know what we know. So I want you to listen to this interview. It's about an hour long. And I want you to really think about three sort of fundamental science questions as you listen to the conversation. The first is, given multiple plausible hypotheses about why the Earth is warming, we need a way to test them. And one of the real challenges here is to think about how you might test a hypothesis for an experiment that's already been done and run only once. And let me explain to you what I mean by that. We have one Earth system, right? We have one Earth, we live on it, and history has happened. The 20th century and now the beginning of the 21st century has happened. We've observed that the Earth system is warming, and we posit that humans are causing that warming. But how do you determine what's causing what in a system where multiple things are changing and there's only one of those systems? If you wanted to test, for example, whether a particular antibiotic killed bacteria, right? You might set up 5 petri dishes with bacteria and add that antibiotic, and have 5 identical petri dishes with that bacteria and no antibiotic. And if the bacteria in the no antibiotic treatment are happy and living well, and the bacteria in the antibiotic treatment are all dead, right? Then you have some certainty that that antibiotic kills the bacteria. And perhaps you have a colleague who does the experiment in a different way with different concentrations of antibiotic or different petri dishes or different temperatures. The more that everybody gets the same result, and no matter how you change things, the bacteria die when you give them antibiotic, the more you're confident that the antibiotic is killing the bacteria. You need to be able to replicate and change conditions and take away factors and add factors and see how they interact. We only have one Earth. So one of the things we're going to talk about a lot in the conversation coming up is how we run an experiment even though we have only one Earth, and how we go back in time and rerun that experiment multiple times to see what happened and why it happened. So I hope you enjoyed the conversation. I certainly enjoyed filming it, and I'll see you on the flip side for the last part of this module.